Okay, so now let's look at what we were doing in the last theorem. And we said we have a function, and if we divide by some linear factor, we can do that. Oh, shoot. I want that to be a Q. And we get this. And we said, okay, that was great. We can use the remainder theorem to evaluate a polynomial. But what if the remainder comes out to be 0? Well, then you have that your function, your polynomial function, equals x minus k times q of x. And so that means that this divided evenly, or x minus k, is a factor of the polynomial. It also means that k is a 0 of the polynomial. Okay, so we get this theorem that says if k is a 0, then of f of x, then x minus k is a factor of f of x. And it also works the other way. If x minus k is a factor of f of x, this is the long way to write it out. Oopsies. Then k is a 0. Okay, so these are very important theorems that we use. And we can say it a little bit better. We can say k is a 0 if and only if. Now, the abbreviation for if and only if is usually that, IFF. That's just like a math abbreviation thing like math teachers use. But it means if and only if x minus k is a factor. And that says the two statements up above just a little bit quicker, okay? So they have this theorem in your book. You can look that up. So if k is 0, then x minus k is a factor. Other way, x minus k is a factor. That means k is a 0. Okay, so kind of beat that one to death. Okay, so now here comes an example. Show that x plus 2 is a factor of this polynomial. Well, we don't want to do the long division here. You could, but we're not going to. We're going to use synthetic division. So our k is -2. So we put that in the box. Pull off those coefficients, 1, -6, -130. And now we know that the remainder is going to be 0 because we are told that x plus 2 is a factor. So we already know the answer here. But bring down the 1. So you might be saying, well, why bother? I'll show you. Okay, so 1 times -2 is -2. I add -8. -8 times -2 is 16. That gives me a 15. That gives me a -30. And that's equal to 0. Okay, but like I said, we kind of knew that was going to happen because we knew x plus 2 was a factor. Now, here's the good news. That means that, we said, okay, f of x is equal to x plus 2 times some polynomial. But here's the great news. Now we know what that polynomial is. So I go down a degree. This is x squared minus 8x plus 15. Now, that means that x plus 2, I'm kind of going the long way with this, but x plus 2 times x squared minus 8x plus 15. If I multiply that out, I get the original polynomial. But here's the really great news. This is quadratic. And we have ways to solve quadratic equations. Quadratic. Okay, so I can factor that polynomial. It factors into x minus 5 and x minus 3. So now I know what f of x is in terms of factors. I know f of x is equal to x plus 2 times x minus 5 times x minus 3. And I also know all three zeros. So the zeros are -2, 5, and 3. Because it was linear, those are linear factors, I'm able to do that, and I know what the zeros are. Now you might say, yeah, but what if that little polynomial there didn't factor? You could use a quadratic equation. You could set it equal to 0, and you could still get the zeros. So that's the nice thing about getting it to a quadratic is you can work with it. Okay, we'll see more of this idea later.